Okay, we are starting Chapter 6 in Algebra 2. You'll see the learning target up here, using properties of rational exponents and radicals to simplify and evaluate expressions. Not too exciting. It's just kind of a basic skill you need to work with more and more complicated algebraic expressions. Be able to handle basically advanced math and calculus is the skill that you'll definitely need. Not too exciting. It's a lot of exponent rules for the most part, and also radical stuff, so square roots, cube roots, things like that. Okay. So use property of rational exponents. First of all, rational. What's the word rational mean? Rate. What else?
Isn't it like real number?
They are part of the real number category. Yes, rational is one of the sets of real numbers. What makes something a rational number but not an integer?
Oh, it's like a whole number. Like
integers are like whole numbers and stuff like that. Rational, ratio, fractions. Yep. Okay. Fractions. So basically, we're going to be working with fractional exponents. Okay. Fractional exponents. And then radicals. I kind of already hinted to what a radical is: a square root, cube root, fourth root, things like that. Okay. So everybody can understand what we're going to be working with here? Exponents, fractional exponents, cube roots, square roots, stuff like that. All right? So, just to get started here, in case you're not familiar with different type of roots, okay, we know this. This is the square root, right? Okay. Square root of 25, you guys know, is 5. Because the square root means what? What times itself twice, right? What times itself twice equals 25. So what number times itself equals 25? Answer 5. So that's a square root. A square root is the exact inverse operation of x squared. Squared, square root. Okay? They're inverse operations of one another. They undo one another, okay? Well, we know that squared is not the only power that we see on the variable x. We'll see x cubed, x to the 4th, x to the 5th, x to the 9th, x to the 11th, okay? Well, how do you undo those then? All right? Well, if you were not aware, some of you probably knew this already, but if you want to undo x to the 5th power, you simply just do the 5th root of x. Okay? X to the 5th and the 5th root of x are also inverse operations. X to the 4th, 4th root. X to the 3rd, 3rd root, or we'll even call it, because sometimes we say x cubed, so we call this the cube root. Okay? Outside of squared and cubed, we really don't have any fancy names for them. It's just whatever number that is. Okay? The 8th root, the 11th root, the 12th root, whatever. Okay? So, everybody understand what it means when you see this right here? The 5th root of something would mean what number times itself 5 times equals that number underneath the radical symbol. Okay? Like the 5th root of 32 is a common one. The 5th root of 32 is 2. Because if you take 2 times 2 times 2 times 2 times 2, you get 32. Okay? Kind of understand? Questions on that? Just as far as what these mean? Okay. If you want to follow along in your textbooks, you certainly can. That's where this next table comes from. I'm on page 414. Otherwise, I'll try to summarize it at least for you up here, just with your notes. One of the things you're going to have to be able to do is name or identify all of the real nth roots of some number a. Okay? You're going to have to identify how many and what are the real roots, the real nth roots of some particular number. Now, because we're only identifying real roots, and again, this is page 414 if you want in your book, 414, okay? Because we're just working with the real roots, what will we not have as far as answers go then? i's. Yep. Okay, we won't be working with 2i or I root 7 or things like that like we did in chapter 4. So we're only working with real stuff. We're not going to work with the complex or the imaginary stuff. Okay? Okay, so we're going to find all the real nth roots of a particular number. First of all, we got to kind of clarify what type of root we're going to be doing here, because they're not all the same. Let's just say n is even, so that means a square root, 4th root, 6th root, 8th root, 10th root, even numbered root, right? An even numbered root. If we're going to find an even root of a, where a is greater than 0, or where a is positive. Okay? So if I said, what are all the 4th roots of 16? Even roots of a positive number. Okay? So name for me all of the 4th roots of 16. What I'm asking you is to tell me all of the numbers when taken times itself 4 times equals 16. 2. Does 2 work? Mm-hmm. 2 times 2 times 2 times 2 would equal 16. Does any other number work? Negative 2 also works. Negative 2 times negative 2 is 4. Times negative 2, negative 8. Times negative 2, positive 16. So do you see how there were 2 answers for that? Anytime you do an even root of a positive number, there will be 2 real roots. Anytime you do an even root of a positive number, there will always be 2 real roots. For instance, what are all of the square roots of 36? What are all of the square roots of 36? 6 and negative 6. Okay? So even roots of positive numbers, 2 answers, 2 real roots. Okay? How about an even root of a where a is 0? So in other words, the square root of 0, the 4th root of 0, the 6th root of 0, the 10th root of 0. What would the answer to all of those questions be?
0.
There's only one answer, and that answer is 0, right? There's only one answer. Okay? The 10th root of 0 is 0. Because 0 times itself 10 times is still 0, right? Okay? So an even root of 0, there's only one answer. It is 0. Okay? How about an even root of a where a is less than 0 or where a is negative? So like the square root of negative 9, the 6th root of negative 64, the 10th root of negative 1,000. The only way to do that is if you change it to a positive, which would involve an I, which means it's not real, so therefore there are no real roots. If you take an even root of a negative number, there are no real roots. There are no answers, no solutions, no real solutions. Okay? 4th root of 16 has how many answers? 2. 4th root of negative 16 has none. No real answers. Okay? Yes? No? Okay? So even's kind of the tricky one. So when you have square roots, 4th roots, 6th roots, even roots, you got to think a little bit. Odd roots, no thinking involved really. Anytime this is an odd root, always one answer. Always, always, always. Okay? For instance, cube root of 8. What number times itself 3 times equals 8?
2.
Just 2. Does negative 2 work?
No.
No, because negative 2 times negative 2 times negative 2 is negative 8. So the cube root of 8 is just 2. What is the cube root of Negative 8.
Negative 2.
No, we can do this. Negative 2 would be your answer. Negative 2 times negative 2 times negative 2. So can you do odd roots of negative numbers? Yes. Can you do even roots of negative numbers?
No.
No. Can you do odd roots of negative numbers?
Yes.
Yes. You can do odd roots of anything. You always get how many answers? 1. Okay? So, real quick in summary of this table. There will always be one answer, except when you do an even root of a positive number, there will be 2 answers. And when you do an even root of a negative number, there will be 0. Otherwise, always one answer. Questions so far? That's just on how many answers there are, or how many real roots there are to these. Now I'll do a few. Okay? Anybody? Questions? Okay. How am I doing?
You're at like 11 and a half.
Let's pause it. Be a good time. Just pause it for a second.